Hey everybody, this is Mr. P, and hope everybody's doing well. And I'm just coming to you with your e-learning lesson for Thursday, May 7th, and continuing with our electricity unit. Today we're going to look at electrical energy. Okay, we've talked earlier in the semester about several forms of energy. Electrical energy is one of those forms. All right, so just recall some things we've done so far with electricity. We looked at Ohm's law, right? Voltage equals current times resistance. Did some calculations with that. We looked at power equals current times voltage in yesterday's e-learning and did some calculations related to that. Today we're going to look at electrical energy. Okay, so let's kind of define how we calculate that. So electrical energy, the energy equals the power times the time. Okay, so what units are we going to be using here? Okay, so the energy is measured in something we call kilowatt hours, so kWh. Okay, so kilowatt hours. Okay, remember a kilowatt is equal to 1,000 watts because kilo means 1,000. All right, just FYI, if you have watts and you want to go to kilowatts, you need to divide by 1,000. If you have kilowatts and you want to go to watts, okay, you multiply by 1,000. Okay, the time for this equation is in hours. Okay, and power, of course, would be in kilowatts. All right, so those units have to be there in order for us to do the calculation. So this is in kilowatt hours, energy. Power is in kilowatts, time is in hours. Okay, and you'll see that for some problems we have to do a conversion in order to get power in terms of the correct units. Okay, there's a lot of practical application we can figure out. We're also going to figure out how much it costs to operate, how we can figure out how much it costs to operate certain electrical appliances based on the rate that your utility company charges. So again, a lot of practical application here. So in our first example, let's roll it on down here. So it says if I leave a 100 watt light bulb on for 8 hours a day, how many kilowatt hours of energy have I used in 30 days? So first of all, okay, 100 watts. Let's just start with that. Remember, for the equation that we need to use, the power has to be in kilowatts. So I have watts. Remember, to go from watts to kilowatts, I need to divide by 1,000. So take 100, divide by 1,000, okay, and then I get 0.1 kilowatts. Okay, that's my power. So remember, energy equals power times time. 8 hours, that's my time. Remember, time has to be in hours. Okay, so let's just calculate how much it costs to operate it in 1 day. Okay, so energy equals power, so it's 0.1 kilowatts times, so 0.1 kilowatts times 8 hours. So what we end up with there is 0.8, okay, 0.8 kilowatt hours. And the question here is, how much energy have I used in 30 days? Okay, so this is just in 1 day. That's how much energy I've used in 1 day. But the question asks how much in 30 days. So all I would need to do is take this, the amount for 1 day, multiply it by 30. So I do 0.8 times 30, and I would find that it would be 24 kilowatt hours. Okay, so again, that's a measure of electrical energy that you use. How much electricity you're using, that's what they base the amount you're charged on. Okay, let's look at another one. It says if 30 kilowatt hours of energy is used, let's stop there. Kilowatt hours, remember, that is our energy. That's the unit for energy here. by a 1500 watt blender. That's the power, but remember, power, it has to be in kilowatts. This is in watts. What am I going to do first? I'm going to do just what I did here. I'm going to divide by 1,000. So the power, I'm going to take 1,500, 1,500 divided by 1,000. So I got 1.5 kilowatts. Okay, so that's what I'm going to use for power. So it says how much time in hours did I use the blender during that month. Okay, so if I use this much energy, 30 kilowatt hours energy, the power used by the blender is 1,500 watts, which is 1.5 kilowatts. I want to figure out the time. So for how much time, that means we have to find T. Find T. So we always go back to energy equals power times time. Energy, we have it, right? 30 kilowatt hours. Power, okay, remember we have to put it in terms of kilowatts, 1.5. Time, okay, so time, we don't know, so I put T times T. What do I do here to solve this equation? I would divide by 1.5, and I would find that you would have a time of 20 hours. Okay, so again, that would be how much time I used the blender during that month. All right, so we're going to look at one more. And give you just a moment to take a look at that, and then we'll look at the last example. So in the last example, you notice that we have a couple different things we're looking at. So the power rating of a typical clothes dryer is 5.4 kilowatts. So our power is already in the correct unit. That's power. Okay. If you use a clothes dryer for 2 hours, what's 2 hours? That's our time. Okay. How much energy do you use? How much energy? Remember, we're trying to find E, and that's going to be in kilowatt hours. Second part of the question, which you'll have one similar to this on your assignment. Okay, that's going to be on Schoology in this folder here. You'll have one very similar to this. So, first part, let's just start with energy equals power times time. Okay. Power, it's already in the correct unit, so I can just put in 5.4. T, that's time, okay, because I got 5.4 kilowatts times 2 hours. And remember, that gives us kilowatt hours. So that gives us 10.8 kilowatt hours. Okay, so that would be how much energy is used by that dryer. And now we want to figure out how much does this cost if my rate, so the rate the utility company charges me is 12 cents or $0.12 per kilowatt hour. All right, so in that 2 hours, okay, here's how I figure that out. I take my energy, so the 2.8 or the 10.8 kilowatt hours times, right, it's 0.12, right, or 12 cents per kilowatt hour. 12 cents per kilowatt hour. And when I multiply 10.8 times 0.12, I would end up with, it's like 1.296, which rounds to, we'll call it $1.30, $1.30. So when we're figuring cost, we want to have 2 decimal places after to the right of the decimal there, because that's how we write dollars and cents. So this would be our cost, right? This is the energy we use. This is the cost. Again, so what we did here is we took the cost times the rate, or not the cost times, we take the energy times the rate, and that gives us cost. Okay, so energy times the rate, and that's going to give us the cost. All right, so again, your assignment for this is in the folder for 570 learning. And until next time, see you guys later.